Every time.
Oh, I was wondering those back.
Okay. Number one, here, we're reviewing for your test tomorrow. Question number one, how do you find the domain of a function? Well, the domain is all the numbers in the world for this problem, except what? We want to look at the denominator, and we don't want what in the denominator?
Zero.
A zero. What do you mean, or one? Well, you don't want a zero. Now let's look at this individual case. You're going to set this equal to 0. So if x squared plus 2x minus 3 were equal to 0, what you would do is you would factor this. Bless you. Whoops.
Don't really stop, it's really gross.
Now what two numbers will give you a 0? Here and here. And that's why he said 1. So x cannot be, it cannot be -3 and it cannot be 1. So if it can be any number but -3 or 1, it can be what? From -infinity to -3, -3 to 1, and 1 to infinity. Some groups were factoring the numerator and setting the numerator equal to 0. That is incorrect. So on your test, I want to see you write your answer in interval notation. It should look like this. Make sure your numbers are ordered correctly. So for example, I've seen some people switch 1 and -3. You know -3 comes before 1. So get them in the right order. Next one, number 2. You're going to look at this and say, well, let me factor the numerator or the denominator. The numerator factors to be x minus 2, x plus 2. Always see if you can cancel something out. You can't for this problem. So we're going to look for what are our critical values. Our critical values are anywhere where you get a 0. So 2, -2, and -1 are the 3 critical values. If you jump down to the exclusion chart, some people do that. Your exclusion chart, you're going to put -2, 1, and 2 in order, like a number line, and then label put your factors, and it doesn't matter what order they're in, and then f of x, right? So what we're looking for in this chart is where you're going to get a negative number for each of these. So what you do is you set x minus 2, find the 0 here. It occurs right here. So to the left of this, these are all going to be negative, this would be positive. This one, your 0 would be right here. This will be negative, these will be positive. And x plus 1, -1, or I'm sorry, so this should be -1. I just wrote that wrong. -1. -1, and then these will be negative, and that'll be positive. Now you count. You have an odd number of negatives, so this is going to be negative, positive, negative, positive. Questions? So now let's go into the other stuff. Your roots. That is where the numerator is equal to 0. So we have 2 roots at 2 and -2. Right away, as soon as I find something, I stick it on my graph so I don't forget. Because some of you guys forgot, and I'm not saying this particular class, but in other groups, they forgot to label, they found the y-intercept but didn't include it in their graph. Well, that's technically wrong. Your vertical asymptote, I would like to see x equals -1. That is a vertical line at -1. So what you're going to have here, at -1, you should have a broken line. Now, this is top heavy, and it's top heavy by 1 degree. Top heavy by 1 degree means there's a slant asymptote. That means there's no horizontal and there's no parabolic. Notice how I'm putting an X on these 2 lines, or you can write, some of you wrote NA, that's good. But don't leave it blank, because if you leave it blank, that might suggest to me that you don't know how to do that and you left it blank. So how do you find a parabolic or a slant asymptote? You do either synthetic, if you can, or long division. I can do some things. I'm gonna put -1 out here, 1, 0, -4. Bring down the 1, multiply, and add. Now, I don't need to go any further because I don't care about the remainder. Don't need it, it's not necessary. It's not gonna matter. So, how do you interpret your slant asymptote? It's y equals 1x minus 1. Okay, graph that. How do you graph y equals 1x minus 1? Well, it's slope-intercept form, begins at -1, up 1 over 1, up 1 over 1, up 1 over 1, and you're going to have a broken line. So let's put our slant asymptote in with a orange line, right like that. Your y-intercept, you have to find the y-intercept. Sometimes there is none. If there is an asymptote at the y-axis, then there is not going to be one, but there is one here. If you plug 0 in here, you get 0, -4. Some people did not actually plot this point. 0, -4 is right. You want to put that dot there because you want your graph to go through that. And there was no hole. So now, how do you interpret this graph? I'm going to show you really quick a suggestion that you can do. So you want to look right here. From -infinity, this is going to be a guide where you go. From -infinity to -2, you want to be in the negative region. So let's find negative, here's -2, and we want to be in the negative region. So you've got an asymptote there. And I kind of give you a little sneak peek of this point right here because you want to pick this up. So you can't be in the blue region. Where would you draw something that would be in the negative? You want to be in the negative region, but you need to pick this point up. So what would you do? You're going to draw something that's going to pick this up right here. Then from -2 to -1, it says you're in the positive region. So you're in between here, and you don't want to be in this region down here, so obviously you don't have much choice, you're going right up there. So that's half of it. And then from -1 to 2, let's find where -1 to 2 is, right there. It says you're in the negative region. So we want to come from this asymptote, pick up that 0, or that, yeah, well, it's a y-intercept, and then you want to pick that up, and then from according to our chart, from 2 to positive infinity, we're in the positive, so you're going to go follow that asymptote. Questions? Next one, number 3. You will factor completely the numerator and the denominator. Here it is factored. X squared minus 1 is x minus 1, x plus 1. This, you're going to take an x out, and you're left with this, and you're going to further factor that. So what you have here is, you're going to cancel one of these x minus 1s. So what you have is x, clean this up, x plus 1 over x times x minus 1. A lot of you guys, I heard throughout the day, people saying, there's a hole. There's only a hole when what?
It's not there.
When you cancel, you lose a factor completely. So you lost x minus 1, but not completely because you still have another x minus 1 right here. Okay, so this one tricked you. There's no hole. So we are actually going to concentrate on this problem right here. We don't need this anymore. It was too much. We don't need any of that stuff. So now, what are our critical values? -1, 0, and 1. So when we do our T-chart, or our exclusion chart, we have -1, 0, and 1. And our factors are x, x plus 1, x minus 1, and then f of x. So quickly, make sure you leave a space after each of these critical values. So this one, you've got negatives here, positives here, negative, positive, 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 Here's your 0, these will be negative, and that's positive. So count, you have a negative, odd number of negatives, negative, even, odd, even. So I am going to look at this bottom row right here. And I'm going to tell you this, for those of you that do not cross this out, you may have extra, like in the next problem that I'm going to go over, your exclusion chart will end up being wrong if you don't simplify it. Okay, where are your roots? Your roots, again, are the numerator, right here, -1. Put a dot at -1. Your vertical asymptotes, since you have them at 0 and at 1, that would suggest, and I'm going to put it, this one's going to be pink. And I'm sorry for that being so tight there between 0 and 1. You're going to have to draw something in between there. But because we have an asymptote at x equals 0, we can't have a y-intercept. Now, this is bottom heavy. The degree on the bottom is a 2. So that means y equals 0 is your horizontal asymptote. And it can't be bottom heavy and top heavy. So this is what your chart should look like. So we have a horizontal asymptote at y equals 0. Now, notice how there's a point right on the asymptote. If it's a horizontal asymptote, remember, a horizontal asymptote is a weak one, and it's for the end behavior. Your graph can cross a horizontal spot across a horizontal asymptote. It's more for the end behavior. So like right here, from -infinity to -1, it says we are in the negative region, but you have an asymptote. So what this means is your graph is coming from -infinity. It's close to this asymptote, and it's going to pick up right here, and it's going to shoot way up there. Yeah. So that's how you do that. Now from 0 to 1, it says we're in the from -1. Oh, I'm sorry. We're from 0 to 1. 0 to 1, we're in the negative. So that's where you're going to have a little skinny parabola. Sorry, it's hard to see that. And then from 1 to infinity, we're in the positive region, so you're just going to draw that. Questions? Okay, number 4. Number 4, when you factored this one, you have x minus 3 times x plus 2, and then x minus 2x plus 2, right? Which, guess what? What do we have? We have a hole. So, where is your hole and how do you figure it out?
-2.
So, it's at -2, comma what?
1 1/4
Yep, and how did you figure that out?
-2.
You plug -2 here, so -2 minus 3 is -5, and -2 minus 2 is -4, which is 5/4. Okay, that means, now what a hole means, see normally you would have an asymptote at -2, right? So instead of an asymptote at -2 5/4, you have a hole. So you can't have any point on right there at -2 5/4. Okay. Your critical values, since our problem reduced to x minus 3 over x minus 2, some students used -2 as a critical value and that messed up their graph. The only two critical values are 3 and 2. That's it. So if you mess up your critical values, it's going to mess up your exclusion chart and it's going to mess up your graph. So what you should have here is x minus 3, x minus 2, and then f of x. Am I going too fast? You guys getting this? So right here, your 0 is at 3. These will be negative and positive, and this one negative, positive. So positive, negative, positive. Let's finish up here. Our root here is going to be at 3. At 3, you're going to put a dot. your x-intercept is 3. Our vertical asymptote is x equals 2. So at x equals 2, I need a vertical line. Okay. Now, this is an interesting, what kind of an asymptote do we have? Horizontal, slant, is it bottom heavy, top heavy? What is it? It's equal to. It has a horizontal asymptote, but since the degrees are the same, you take the leading coefficient of the numerator over the leading coefficient of the denominator. So y equals 1, and I need to see the graph of that. I need to see all this stuff correctly put on here. Now we have a y-intercept. If you plug 0 in for this, what's left here, 0, you get 3 halves, which is 1 1/2. So it's hitting the y-axis at 0, 1 1/2, which is right here. So now let's put our information here. From negative infinity to 2, so from negative infinity all the way to 2. Now if you want to look at it like this, here's 2, and here is negative infinity. It says we're in the positive region. So what are you going to draw? Should we be below here?
No.
Because that's positive. No, because you want to pick up these. So you're going to come from here. Now you're not going through that hole, you're skipping it. You're going to pick up your point 1 1/2, and you're going to shoot up. You're still positive. Does that make sense? Now from 2 to 3, it says we're in the negative region. 2 to 3, that's not much. You're in the negative, so you're that little skinny little area, you're in the negative. Now I don't want to see this. That's wrong. Why is that wrong?
Because you crossed.
You're not crossing. Think of a vertical asymptote as like a down wire. If you were to touch it, and they ever tell you don't touch down wires, you get electrocuted. You can't cross it. You get zapped. So think of it like that. You don't want to touch it. So, and then it says from 3 to infinity, you're in the positive region. Now, I saw some groups go like this. Is it going to do that? No. It's going to stay underneath. It's going to get closer and closer like that. Okay? Last one. Trevor, how do you factor this?
Well, it was actually, I wasn't sleeping, I was done listening.
How do you factor this?
Well, you take an X out,
Okay?
and X squared plus, minus X plus 6, and then it's, negative X minus 6, X plus.
How about minus 3 plus 2?
That. Oh, yeah, it would be 2 minus 2.
Thought so. Okay, what are all the critical, can I cancel anything out?
No.
I wish, right? You got 1, 2, 3, 4 critical values. They are 0, 3, negative 2, and 1. So let's do our exclusion chart right now while we're at it. What's the smallest of these numbers? Negative 2, then 0, then 1, then 3, right?
So you're 2013.
Huh?
It's the negative 2013 one.
Oh, yeah, it's 2005. Okay, now, are you guys okay with this exclusion chart? Do you understand how to fill this in?
Oh, yeah.
Okay, tell me what to do. Tell me.
You gotta finish the lines.
I know. I finish these lines. And when I don't do them, I get confused.
Okay,
So,
so at X, you're gonna put a dot on the 0. And
Yeah.
to the left of that's gonna be negative.
Good job.
Right to positive.
Then,
Dot,
yeah,
left,
uh-huh,
dot, negative 2.
uh-huh,
Negative, positive, positive, positive. 1,
uh-huh.
yeah. And then, positive, negative, positive, negative, positive.
And how'd you get that?
Because it's odd and even.
odd, even, okay, good. I should say even, odd, okay. How do you find the roots? What do the roots mean?
It's the numbers from your memory.
What do I do with those three numbers? Do I do anything with them?
What the?
So, as soon as I did that at 0, I got another answer. What's that answer? Yep, y-intercept. So I got another answer, 0, 0, what, 0, 0. Was there a hole? We answered that question. Was there a hole?
No.
No, we didn't cross anything out. Okay, vertical asymptote, x equals 1. So we're gonna, x equals 1, here it is. Some of you guys forgot that. Forgot to draw that. You all knew that there was a parabolic asymptote. So if there's a parabolic asymptote, that suggests that the numerator has a degree of 2 more than the denominator. But how do you find the equation of the parabola? What do you do? Now, can I do synthetic division? Why? Because you can, because it has a degree of 1 and a leading a degree of 1 and a leading coefficient of 1, so you can. So bring down the 1, 1 times 1 is 1, add, and actually you're almost done. There you go, you're done. What is this? Y equals x squared minus 6. I need you to be able to all graph that. How do you graph y equals x squared minus 6? This
You
goes
go
back
down
to
6.
so you go down 6, 1, 2, 3, 4, 5, 6, and you just graph your parabola. Over 1, up 1, over 2, 1, 2, 3, 4, over 3, 1, 2, 3, whoops, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and draw your dots. Okay, now we have to put all of our information here. From negative infinity to negative 2, it says we are in the positive region. So what you're going to do, this is where you guys got confused. Right here. I'm going to show you this really quick. Where would you be if you were in the positive region? Where would you go? This is the region I'm looking at.
Left side.
You would go here?
No,
Yeah, inside. Yeah, you go inside. Then from negative 2 to 0, it says negative. So you're going to come down, and then it says positive, then you're going to shoot back up here. So you've got like a parabola within the parabola. Now, the last thing. You've got from 1 to 3, it says negative. So here's 1 to 3. You're in the negative region. So where would you go?
Outside the parabola.
Out. So you've got 2 asymptotes, and I know it's kind of hard to see. You go here, and then from 3 to infinity, it says positive, so you're just going to continue on outside of that parabola. Now, this one was a little bit more challenging, but I thought with a group of 20,
I'm mad.
you should be able to do it, right?
We got it.
And we got,
Hey,
oh,
actually,
I know.
there was like
Team
You
Hundo.
should be able
5
to
people
do
that got it.
Hey, so Miss Audrey.
And I think that these guys get some credit for.
Thank you. That's all I want is credit.
Yeah.
Just give them full credit.
Okay, so test is tomorrow,
Miss
right?
Audrey, can I run to my car and